So today we are going to talk about trig of some special angles. Particularly today we're going to talk about trig of angles that lie right on one of the axis lines. So we learned in our last lesson that when we graph an angle, we graph them on xy axes. We learned that we begin at the positive x-axis, which is the 0 line. And then each quadrant is 90 degrees. So we can count up around 90 straight up. 180 would be halfway around. Another 90, 270 would put us at the bottom. And if we go all the way around, 360 would make a full circle. Then we also learned in our last lesson about these things called radians, that a radian is another way to measure an angle. Does anybody remember what the conversion is? Like 12 inches is 1 foot? How do radians and degrees relate to each other? Pi over 180. 180 is equal to pi. So the 180 on the circle is the same thing as pi radians. So 0 would still equal 0, and if we go all the way around, that would make 2 pi. If 180 is 1 pi, then 360 is 2 pi. So what's halfway between 0 and 1 pi? Half of pi. And we usually write it as pi over 2. Instead of 1/2 times pi, if you write 1/2 times pi, that's fine. It's just more writing. So we write it as pi over 2 because it's less stuff to write. What's halfway between 1 pi and 2 pi? 1.5 pi, but we usually write it as 3 pi over 2, again, just because it's less writing. If you wrote 1.5 pi, that's fine. It's correct. We just usually write it as 3 pi over 2 because it's less stuff to write. So these angles are going to be special angles for us that lie right on one of those axis lines. We're going to find some trig values. So we've talked about sine, cosine, and tangent. But instead of using triangles and thinking about SOHCAHTOA, we are going to use a circle. Because remember in a right triangle I said that we're not ever allowed to let the 90-degree angle be our theta, because 90's opposite is the hypotenuse, and 90 has two adjacents, so that makes trig not work so well in terms of SOHCAHTOA for a 90-degree angle. And it would be likewise for any multiple of 90 going around. So instead of using a triangle, we're going to use a circle. Yes. We're going to use what's called a unit circle, which means the circle has a radius of 1. We're going to label the 4 points where this circle hits these axis lines like x comma y. So at the 0 line, that would be over 1 up 0. Just like graphing in algebra, that point would be over 1 up 0, x comma y. Up at the top, that point would be over 0 up 1. Over on the left-hand side, that point would be back 1 up 0. And at the bottom, that point would be over 0 down 1, just like plotting those points x comma y like in algebra. Each of those 4 points gives us 2 trig values. It gives us alphabetically cosine, comma sine. You may see a new symbol which looks like a 0 with a line in it. It is the Greek letter theta, and it's just a letter that we use to represent an angle. So when you see that kind of 0 or O with a line in it, that's called theta, and it's just a letter that we use to represent an angle, just like we use x in algebra to represent a number. So each of those points gives us the cosine and the sine of that particular angle. There were 3 trig functions we talked about, though. What was the third one? Tangent. Tangent is equal to sine divided by cosine. We are going to use this picture to solve the next type of problem that we're going to talk about. You need to be able to recreate this picture for the quiz. So we need this picture to solve the problem that we're going to look at next, and I'm not going to give you this picture on the test. So you need to be able to recreate this picture. So we count around our 90s and then convert into radians. And each of those points is an x comma y, how far over, comma how far up or down. Okay. Cosine comma sine, alphabetical, just like x comma y. And tangent is sine divided by cosine. So this question says evaluate the 6 trig functions for theta, our angle, being 180 degrees. So first thing we're going to do is recreate the part of the picture that's important to us. So 180 is out to the left. That point that was on the 180 line is negative 1, 0. Back one up 0. That point gives us alphabetically the cosine and then the sine, and tangent is sine divided by cosine. So our 3 trig functions, sine, cosine, and tangent, are given by that point on the 180 line. Alphabetically, the first part of the point is cosine. So that means cosine is equal to negative 1. Cosine comma sine, so sine is the second part of the point. Sine is 0. And tangent is sine divided by cosine. What is 0 divided by negative 1? 0. So we get 0 there for that last one. There are 3 more trig functions that we haven't talked about. They are the reciprocals of the first 3. What's reciprocal mean? Backwards, opposite, or if I'm thinking about a fraction, flip it. Okay, so we're going to think about flipping over fractions. So these 3 trig functions, the first one is called cosecant, and we abbreviate it CSC. And that's the reciprocal of sine. The second new one for us is called secant, and we abbreviate it SEC. That's the reciprocal of cosine. And the last one is called cotangent. We abbreviate it COT, and that's the reciprocal of tangent. Students are usually okay with matching up tangent and cotangent, but often get confused when matching up the other ones because we want sine to match with secant and cosine to match with cosecant. We kind of want those cos to match up. But think about it this way. When people are flying a plane, there has to be one pilot and one co-pilot. We can't have 2 pilots because then who's in charge? So every pair has to have a co. So we want sine to match with cosecant and cosine to match with secant. So each one of those pairs has a co. All right? Then there are the rest of the first 3. So we'll start with cotangent. We'll start at the bottom and work our way up. Tangent was already written as a fraction. So I can take it and flip it over, and it becomes negative 1 over 0. What do I get when I divide by 0?
0.
Undefined. You are not allowed to divide by 0. Dividing by 0 is the biggest no-no in mathematics. Dividing by 0, 0 on the bottom of a fraction, is a big, big, big no-no. So 0 on the bottom of a fraction is undefined. Working our way up, we can make anything to a fraction by putting it over 1. So I can write that cosine value over 1. And when I flip it over, I get 1 over negative 1. And what is that? Negative 1. And again, for sine and cosecant, we can put anything over 1. So then when I flip that over, it becomes 1 over 0, which is undefined. 0 on the bottom is a no-no. 0 on the top is 0. 0 on the bottom is undefined. When you take a 0 and flip it over, it will become undefined. When you take a 1 or a negative 1 and flip it over, it will still be 1 or negative 1. 0 will always become undefined when you take its reciprocal. Let's try another example. This one has our angle given in radians. Where's the angle for pi over 2? At 90. So 90 pi over 2 is the angle we're looking at, and the point there is 0, 1. Remember that point is alphabetical, cosine comma sine, and tangent is equal to sine divided by cosine. So our first three trig values are given to us by that point. What is the sine? 1. It's the second part of the point. What is the cosine? 0. It's the first part of the point. Tangent is sine divided by cosine. And what does that become? Undefined. 0 on the bottom is undefined. The other three are cosecant, secant, and cotangent. And they are the reciprocals of the first three. So if I take that sine value of 1 and make it into a fraction 1 over 1, what do I get when I flip it over? 1 over 1, which is 1. If I take that cosine value of 0 and make it into a fraction, what do I get when I flip it over? 1 over 0, which is undefined. Zeros will become undefined when we flip them over. If I take that tangent value and flip it over, it becomes 0 over 1, which is 0. 0 on the top is 0. So zeros and undefined will go back and forth when we do our flipping. One part of the partnership will be undefined, the other part will be 0. Ones and negative ones will stay what they are. Questions? I think you need to try one. So, there's not another one in your notes, but I will have you try to find the 6 trig functions for theta is equal to 270. And by recreating the part of the picture that will be helpful to us, or you can just reference it since you already have it drawn out. 270 is straight down in our circle, and that point is over 0 down 1. So for our first 3 trig functions, sine, cosine, and tangent, we take them directly from that point alphabetically. So the cosine is the first part, the sine is the second part, and tangent is sine divided by cosine. 0 on the bottom is undefined. For the other 3, we take the reciprocals of the first 3. When I flip over a negative 1, it will still be negative 1. When I flip over a 0, it becomes undefined. And when I flip over an undefined, it becomes 0. Questions? In our last lesson, we learned how to graph angles. Today I'm going to define a new term for you called a reference angle. A reference angle has 3 key characteristics. It is acute. What does acute mean? Less than 90. It is always going to be positive, and when we graph our given angle, it will always be the angle that is next to the x-axis. Acute, positive, and next to the x-axis. So we learned how to graph angles in our last lesson. We learned that we graph them on an xy axis. We learned that we start at the positive x-axis. Which direction do we go around our circle? Counterclockwise. So if I go counterclockwise 390 degrees for the first example, where will that end up? 320 degrees counterclockwise around the circle will end up in the bottom right quadrant. How far away from the closest x-axis? 40 degrees. 320 is 40 short of being the full circle. That 40 is the reference angle. So I was already in the last lesson having you put that number into your angle when you graphed it. That angle has a name. It's called the reference angle. So some of you are wanting to put your number next to the y-axis and say that like 320 is 50 past 270, which is true, but not helpful. A reference angle should always be next to the x-axis. So that's why I was having you put the number there instead. In our last lesson, we also learned how to graph in radians. So how do I graph in radians? I have to divide up the circle. How do I divide it up? So we could use those numbers that we had in the last one, like 0 and then a half a pi at the top, pi halfway around. So if I'm dividing into pi over 6s, how do I do that?
You put 6 parts at the top and 6 at the bottom.
Each half of the circle breaks into 6 parts. So whatever the denominator is, each half of the circle needs that many. So I need 12 pieces all the way around, 6 pieces in each half. Then the rest of that fraction tells me how big to go for my angle. I want to go -5 of these pieces. What does the negative make me do?
Go backwards.
Go backwards around, and I go around 5 pieces backwards. And my angle ends up right here. So our reference angle belongs right inside of there. How big would that angle be?
10. 6. I don't know.
30.
30. How'd you get 30?
Because you take the 1/3 of 90.
Okay, so you could think of it as being 1/3 of 90, or since we divided each half of a circle, 180 is half of a circle, we divided that into 6 pieces. 180 divided by 6 is 30. So our reference angle there is 30. Pi over 6 is going to be very important to us. We're going to graph a lot of pi over 6s. Okay, the numerator will change, but that denominator of 6 is going to be something that we graph frequently. For the next one, if I graph 140, it's a positive 140. Start at my 0 line, go around counterclockwise, and where does it end up? 40 away from 180. So 40 is our reference angle. 40 is not always your reference angle, it just happened to be in these two examples. For the next one, I'm graphing in pi over 4s. So how many pieces do I need to cut into here? Each half into 4 pieces. So 8 pieces total around, 4 in the top, 4 in the bottom. Start at my 0 line, and I want to go -3 pieces. So how big is that reference angle going to be?
45.
45. 180 divided by 4, or 90 divided up by 2, will give us a 45-degree angle there. Pi over 4s are going to be important to us. We're going to graph those a lot. I have one more example of this type for us here. And for that example, I want us to look at 2 pi over 3. When we divide into odd pieces, we will want to ignore our y-axis because dividing up into 3 pieces on the top and bottom, a vertical line does not help. So I'm going to ignore that vertical line so I can cut the top and bottom each into 3 pieces, 6 pieces all the way around. For 2 pi thirds, I want to go around counterclockwise 2 pieces. And how big is that angle there?
What's on the
60. We have a 60-degree angle in there. 180 divided by 3 is 60. So since I cut half of a circle, or 180, into 3 pieces, each of those pieces is 60. So our reference angle is 60. We will be graphing pi thirds a lot. So these 3 radians are going to be important to us. Pi thirds, which turns into 60, pi fourths, which turns into 45, and pi sixths, which turns into 30. So 60, 45, and 30. Ring any bells? Why do you think those are going to be important to us?
Triangle.
Those are our special triangles. So for the next type of problem, it would be very helpful for you to remember the special triangles that we've studied. Our 30, 60, 90 triangle and our 45, 45, 90 triangle, which are patterns you were supposed to have memorized a while ago. It will be also very helpful to you if you remember SOHCAHTOA. So we're going to look at this next type of problem tomorrow. We are going to stop here for today, but for tomorrow, if you can be comfortable with these 2 triangles and comfortable with SOHCAHTOA, the lesson will go much better for you.